The cosmic landscape is poised to capture global attention at the end of October, thanks to an astronomical event of rare significance. Astronomers and scientists around the world are in a state of maximum preparation to closely monitor what will happen specifically on October 29th, the date on which the recently discovered interstellar comet 3I/Atlas will make its closest approach to the Sun, reaching perihelion. This unique passage, which promises to be the pinnacle of observations of an object that has traveled from distant galaxies, has mobilized tracking systems and telescopes, transforming space observation during this final week of October into a potential milestone in understanding bodies that traverse the vastness of space. 3I/Atlas was identified on July 1st, 2025, and was initially detected by the sophisticated ATLAS, Asteroid Terrestrial Impact Last Alert System, deployed in Chile. This object immediately aroused enormous interest, representing an incredibly rare phenomenon in the recorded history of astronomy. It is only the third interstellar body to be formally confirmed and catalogued, a fact that places it in an elite category alongside notable precursors such as Oumuamua and 2I/Borisov. Interstellar status means the comet did not form in a cloud of gas and dust that gave rise to our solar system, but rather in a distant star system. Because it originated from outside and followed an escape trajectory, it will never return to the solar neighborhood, making this observation window its first and last. Despite the scientific euphoria, it is essential to clarify that the arrival of 3I/Atlas poses absolutely no risk to Earth safety, dispelling any alarmist headlines. The object is following what astronomers define as a hyperbolic orbit, an open trajectory that demonstrates its transitory nature and its inevitable permanent exit from our system. At its closest approach, the comet will remain at a safe and considerable distance of approximately 270 million kilometers from our planet. This distance, while ensuring our protection, still allows for in-depth observation, ensuring that the event is purely a research opportunity and not a cosmological threat. Indeed, the true value of this interstellar comet lies in its potential to reveal cosmological secrets that have been guarded for billions of years. Its approach and subsequent detailed study promise to provide extremely valuable scientific data that can help redefine not only the limits of the universe as we know it, but also answer fundamental questions about the genesis of matter. As a fragment of a completely alien solar system, it brings with it chemical elements and physical characteristics that were not influenced by the initial conditions of our sun's formation, thus acting as a powerful tool for comparing different planetary and star formation processes occurring in the Milky Way and beyond. The first and most crucial scientific observations were conducted with the unparalleled capabilities of the James Webb Space Telescope, JWST. These initial studies brought an immediate surprise regarding the comet's volatile composition. The dense gas head of 3I/Atlas contains an astonishing 8 times more carbon dioxide than water. This pattern of carbon dioxide richness and relative water scarcity is extremely rare compared to the typical composition of comets originating in the Kuiper Belt or the Oort cloud of our solar system. Such a chemical imbalance strongly suggests that the comet must have formed in extremely cold regions incredibly distant from its home sun, in an environment where starlight never penetrated, preserving more volatile ices that would easily sublimate closer to a star. Complementing the surprising profile of its ices, other optical and metallurgical characteristics of 3I/Atlas defy existing categorization. Analysis of its light revealed extreme negative polarization, an anomaly in terms of interaction with stellar radiation. Furthermore, the detection of metallic elements revealed a unique combination, a high concentration of nickel combined with a surprisingly low concentration of iron. In comets native to our solar system, these proportions tend to be much more balanced. This particular metallic signature, along with the polarization, indicates that 3I/Atlas must have undergone an accretion and formation process under exotic chemical conditions fundamentally different from any we have mapped on our own stellar neighbor. This rare and intriguing combination of CO2-rich ices, extreme cold, and unusual metal signature, high nickel/low iron, points to a highly specific and unexplored origin scenario. Such evidence leads scientists to postulate that 3I/Atlas was forged countless billions of years ago, possibly in the darkness of the Oort cloud of a different star system, or, perhaps, in the icy depths of a primordial nebula, even before that star system fully consolidated. Consequently, the interstellar comet is not just a space rock. It constitutes a veritable galactic time capsule, carrying within its composition preserved information about the physical and chemical conditions of the universe in the distant past and in a distant location. Therefore, while the media focus tends to exaggerate its rarity with alarmism, the scientific community treats this event exclusively as an extraordinary opportunity. 3I/Atlas represents unprecedented access to virgin material, uncontaminated by the thermal and chemical processes prevalent in our solar neighborhood. This in-depth study will not only pave the way for a more precise understanding of planetary formation and smaller bodies, but will also help decipher the architecture and composition of the Milky Way itself as a whole, providing vital comparisons with the material found in our solar system. Ultimately, the passage of 3I/Atlas on October 29th serves as a vibrant and tangible reminder of the dynamic and immeasurable nature of the cosmos. Even as we focus on the complexities of life on Earth, the universe is in constant turmoil and motion, continually revealing strange and unexpected objects that challenge our current knowledge. The chance to study this intergalactic time capsule reaffirms the vastness of the mysteries that still persist in the cosmos and the exciting reality that the next great scientific discovery could be just passing through at any moment.